Let's talk about building and testing reliable SQL servers. Now, the reason why I put this module first is that I want to explain what it really looks like to build a permanent, long-lasting, reliable SQL server. I have a philosophy now that when I build a brand new SQL server, I don't want to touch it again for 2 to 3 years. I want it to just be that granite, rock-solid box over in the corner that just takes a licking and keeps right on ticking, and I just don't have to worry about it. I don't want to build another janky, unreliable cluster because I have a bunch of those already. If I keep building up all kinds of houses of cards all around me, then I'm not making things better. So I'm going to talk about what it takes to build something reliable enough that it stays with you for 2 or 3 years. First, I'm going to talk about how you build and test the high availability portion. Second, I'm going to talk about testing role swaps for disaster recovery. That's going to be after the bio break, though, just until the first bio break. We're going to focus on testing high availability. In order to do this, I'm going to pretend that we're building a 2-node cluster in our primary data center. I've got a little drawn line across the middle of, oops, I'm drawn, there it goes. I got a little drawn line here across on the screen. Everything above is my primary data center, everything below is my disaster recovery data center. I have what your grandpa used to call an active-passive cluster. These days we're trying to call that a single instance cluster because it has one running instance of SQL Server here. I have this single instance cluster, say maybe it's SQL Server 2016. It also relies on a SAN. I don't have the SAN pictured here. Every 5 minutes, 10 minutes, we're doing transaction log backups over to a backup file share and restoring them over on our disaster recovery SQL Server down here. This is my goal, and most people think of the wizard as the finish line. The wizard's not even the starting line. There's a bunch of wizards inside Microsoft products that I love. Wizards are awesome. Don't get me wrong. They automate a lot of stuff that I really don't want to have to be doing. But what's involved in building this has nothing to do with the wizard. The first step that you're going to go do is you're going to go lay down your standard build of Windows. And I say your standard build of Windows these days, even for clusters, you only need Windows Server Standard Edition. If your company standardizes on 2012 R2 or Windows 2016, I don't know a lot of people standardizing on 2016 just this early. Then go update all the firmware and drivers on the machine, and I want you to install the hardware management layer. So like HP System Insight Manager, IBM, what do they call that thing? IBM Director, Dell Open Manage. These are web-based tools that show you what kind of shape the hardware is in, whether or not the hardware needs additional drivers updated. This may be something that your systems administrators do. I've got posts on our site explaining how to install HP System Insight Manager, for example. It takes a couple of days the first time that you get this in and get it installed correctly. But the beauty of this stuff is it'll, for example, send you emails when a hard drive dies or when a power supply fails. Things that ordinarily I wouldn't know unless I went into the data center and saw a little blinking light. If I'm running Windows Server 2012 R2, I'm going to install the clustering hotfixes. These are additional hotfixes above and beyond what you see in Windows Update. Windows Update isn't enough if I'm going to start running a Windows Server failover cluster. Then I'm going to use our SQL Server setup checklist. That setup checklist is divided into a few parts. I'm only going to go up to the part where right before we install SQL Server. So this includes things like setting up a security account, configuring the page file correctly, configuring the drives the way I want them to be formatted. And then I'm going to configure network teaming and test it. As an example of what I mean by how thorough I want each one of these lines to be, I'm going to dig a little deeper into configure network teaming and test it. Because Windows clusters these days, especially if you're rolling with always-on availability groups, cluster quorum is so incredibly important, and we're going to talk about that this week. If you lose quorum, especially if you lose network connectivity, for even 10 seconds, your whole entire SQL infrastructure can come crashing down. So I need my cluster to not be relying on just one cable. I need every SQL server configured with 2 different network connections, going to 2 different network switches, so that if I lose one patch cable or if I lose a switch due to firmware upgrades, that this thing keeps right on trucking. In order to test it, here's what I mean by testing network teaming. I want you to remote desktop into one node of the cluster. Then while you're connected, I want you to copy a file. You can use drag and drop, Xcopy, whatever you want, to copy something from one network location to another network location. While that's happening, I need the sysadmins to black hole one of the network ports. Black holing means that I hook that network port up to, say, a totally different network like the DMZ. I don't want to down the port. Windows is really smart. When a port goes down, when it's electrically deactivated and no electricity is coming through on that port, Windows is like, oh, this port is totally dead. I better go switch over to the other one. I need to simulate the much more common failure of there's electricity here, but the data's not going anywhere. That's what black holing is, like if I suddenly map it to a different VLAN. Then, when I do this, while I'm doing it, my file copy and my remote desktop session may pause. They cannot error out. If the file copy errors or my remote desktop session errors, don't stop. We don't go any further. And the Windows team has to go back to configuring this heartbeat failover stuff. I say heartbeat failover. This is not a heartbeat network for a cluster. This is just our plain old regular networks. This slide may be done by your sysadmin team, but this is the kind of thing that I want everybody to walk through and feel comfortable with. Then I want to repeat that exact same process with Power, shared storage, and local storage. For example, with Power, today's modern servers, they come with 2 redundant power supplies, but they're not redundant if you load up RAM in the server. Take Dell's entry-level power supplies, for example. As soon as you fill up the server with RAM, suddenly these power supplies are both required in order to get the electricity up and running. And if you yank one power cable, this server's going brown. You can buy uprated power supplies that take care of that for you. I just need to know that we're set. And if my sysadmins happen to buy their memory from a different place that they bought the server from, the server builders may not have known that I needed those upgraded power supplies. So same thing here. While a test is running, I'm going to simply yank one of the power cables, wait for 30 seconds, plug it back in. The server still should be completely up. After 30 seconds, go yank the other power cable and then put it back in. Same thing with local storage and shared storage. I'm going to simply down one of the SAN ports or black hole one of the SAN ports, and all my connectivity should still be going over through the other side. I'm going to use Crystal Disk Mark, and we'll talk about that through the course of this week. I'm going to do all of this on every SQL server in here. So I got 2 nodes in my primary data center, and I got 1 node down in my disaster recovery data center. He may not even be in the cluster. He's just a log shipped secondary right now. I'm still going to run these tests over there because I need to know that my DR environment is going to be reliable. Remember, sometime during the course of my 2 or 3 years, I'm probably going to fail over to DR. I need that thing to work successfully when I go fail over. There's no wizard for any of this stuff because it's hard. It happens outside of just Windows, for example, with the systems management tools. Then I'm going to test storage throughput with Crystal Disk Mark a little deeper. For every volume that I have, where my data files go, where my log files go, where my tempdb goes, and usually even my laptop, I'm going to go run Crystal Disk Mark, or Disk Speed as well. I like both of those tools. What I'm aiming for is 200 megabytes a second of reads per core. For every core in my SQL server, I want to see 200 megabytes per second. So if I have 4 cores, I want 800 megabytes per second of reads. If I have 16 cores, I want 3,200 megabytes a second of reads. If I also want to run this against my desktop or laptop so that I can say, all right, guys, here's what my desktop looks like. Here's what the production SQL Server storage looks like. Is this cool? Because this is, of course, your one chance to do this before you layer on SQL Server. As soon as you layer on SQL Server, everyone says the same thing. It must be a SQL Server problem. The hell it is, but I can't convince people of that unless I test it ahead of time. Now, everything to this point, in the larger that the company is, and especially when I'm talking to a group of senior DBAs, the larger that the company is, often there's a wall between the people who do Windows stuff and systems admin stuff and networking and storage and VMs. There's a separate team that does that. I give them this exact PowerPoint, or we build it into an Excel worksheet, and I say, here you go, guys. You fill this out. Just check initial and date for every node that we have. I did this on prod 1 on December 8th. I did this on prod 2 on December 9th. They're going to initial and date through the whole thing. Then when it's time to hand off to the DBA team, when they're going to go give us those SQL servers to go build it on, they aren't just going to give us the signed PowerPoint. We are actually going to walk through that test together. We are going to do the down port test. We're going to do the electricity test. Because like Ronald Reagan said, trust but verify. You want to trust your teammates. You just want to make sure that something didn't happen, that someone didn't sign off on the wrong thing accidentally, or that something hasn't been broken since the time it was originally built and then it's being handed off to us. It will only take 2 hours max in order to run through all these tests. The second time you do them, it is not uncommon for this to take weeks the first time it happens. Classic example, the configuring network teaming thing. I had one team who was absolutely positive. They understood what network teaming was. We went to go test it, and of course, immediately the SQL Server drops offline. Everyone learns valuable lessons there the first time you do this. Now, I'm at the point where I'm going to build the Windows cluster. Not installing SQL Server yet. I'm just building the Windows cluster. First, I'm going to document and design how I want to do DTC, Distributed Transaction Coordinator. This starts to matter more in SQL Server 2016, which finally supports DTC with always-on availability groups. Alan Hurt has a good post in here, and it's a little bit outdated, in the sense that it's for Windows 2008. All the basic theory is still correct, though. The world is eagerly anticipating him finally delivering the new version of his book for Windows Server 2016, but it's been in production for 3 years now. Design how you want to do quorum. We're going to talk about that in this exact class. And then we're going to run cluster validation. That is a wizard. Finally, we have a wizard inside here. Failover cluster validation just goes and looks at all your nodes and makes sure that they're suitable to join together into one big transformer. What was it? Optimus Prime? Optimus Prime. This is what happens when I even just go the slightest bit off topic in the morning. I'm like, and then, so then I can tell you about the robots that assembled in order to build him. No, I can't. I want to save my cluster validation report on a network share for proof, because if you have some kind of problem and you go on the phone with Microsoft and they go look at your cluster validation, they go, yeah, no, this doesn't pass cluster validation. One of the first things they'll want to do is help you get past cluster validation. You'll have a much easier time if you have a recent cluster validation that you can say, see, it did pass. It's just that we made one small change 2 weeks ago and we didn't rerun it since. Then after I create the cluster, I'm going to go install SQL Server. We're not going to talk in detail about that here. I've got a whole checklist on our site on how to go about doing that. Things like configuring tempdb files, how you set up instant file initialization. Then you're going to go install any utility scripts that you use, say Ola Hollengren's maintenance scripts. You're going to restore all your production databases. We are not going live yet. All we're doing is giving you more playtime stuff, because from this point forward, the SQL Server is considered production. It's production for us. It's not production for the end users. I'm going to start setting up my backups in CheckDB, and I'm going to load test them. I want to see how fast my CheckDB can go. Same thing with my backups. and I'm going to try different tweaks. This is my one time to do quick repeated tests to see just how fast I can get it to go. CheckDB, starting with 2016, takes a maxstop parameter. So now I can choose different maxstops and see where the sweet spot is for CheckDB. In our testing at Dell DBA days, for example, on one particular server with the Stack Overflow database at about 100 gigs, we saw CheckDB times were the quickest when we did maxstop 14. We tried several different ones, and there was a diminishing return after maxstop 14. If you're not on 2016, you can use tricks like the resource governor, which we'll talk about, to put CheckDB in its own pool and give it a different maxstop. If you're on one of those servers that has set maxstop to 1, remember, that affects CheckDB and your index rebuilds too if you don't hint those guys. Often we find that if you just simply back up to 4 different files, if you stripe your backups across 4 files, your backups usually go 4 times faster. Now, that isn't a hard and fast rule because it can depend on how fast your network speed is and how fast the disks are that you're writing to. We've got a link to Microsoft SQL Cat white paper on how you go about performance tuning backups there. This is your one time to go do that. Same thing with performance testing any loads that you have, like regular repeatable nightly log shipping jobs or nightly batch reporting jobs. Then, now I've got my cluster set up and I've got a third SQL Server down in DR. I'm going to configure log shipping, and I'm going to start pushing those production databases down to the second data center. We're not production yet. I'm still playing and testing because all I have at this point is the same infrastructure that I'm going to have after we go live. Your job now is to break it 3 different ways. The first way that you're going to go break it is you're going to do a planned failover without data loss. When I say planned failover without data loss, you're going to act as if, say, it's a patch window. You're going to go patch the secondary, do a planned failover from the primary to the secondary, patch the former primary. You're going to fail all the way down to disaster recovery, as if you know a hurricane is approaching or that you have to evacuate the primary data center due to lease changes or whatever. You're going to screenshot and document the whole thing because you're going to build a little checklist so that anyone can walk through this. Anyone's the wrong word. This is really for people like us, but it's just so that I can swap out any member of my DBA team, especially the more junior members of the DBA team, and have them follow a checklist. The second way I'm going to go break this is I'm going to do an unplanned failover with data loss. I'm going to assume that I lost the primary data center. For example, one of my favorite ways to do this is simply go walk into the primary data center or have my sysadmins do it and simply yank the cables out of the production primary database servers. Of course, we can only do this for testing before we go live with this thing, but that's what this whole experiment is about. Or yank the storage cables out or simply down all the storage ports at exactly the same time. Then I want my DBAs to go connect to DR because they can't see the primary. Go connect to DR, tell me how far behind it is, tell me how many minutes of data loss we're going to have. Because that's exactly the question that you have to answer with management, right? Whenever you lose the primary data center, management wants to know how much data we're going to lose before we fail over to it. You'll see just why that's so critical today. I'm going to walk through the process of bringing the DR site live, checklisting and screenshotting all that out, again, so that I can have the more junior members of the team go tackle this. If you've never been through a data center failure, here's what happens. Everyone assumes that the smart people are going to be working on the failover. You don't have that many smart people. You have a lot of people who would really love to help, but they've never done any of this before. And when you let them loose to start working on something, this is when data loss happens. This is when server loss happens. I had one incident during a disaster recovery failover where someone deleted the entire backup share down in DR because they were worried about running out of space. They saw that it was a huge share and they went, I've got an extra copy of this over on the other SAN, except they did not. The third way that I'm going to go through and do this, or the third failure that I want to troubleshoot, is after I've lost the primary data center and I've failed over to DR, I want to bring the primary data center back online with no data loss. I'm going to start setting up, in our example, log shipping going from the DR data center up to the primary data center. Then, as soon as I've got these guys in sync, then we're going to fail back up to the primary data center. Again, we're going to screenshot and checklist this whole piece out. Those are the three mandatory ways that I have to break my cluster and my log shipping. But then for bonus points, if you want to be really good at troubleshooting, we play the outage game. We get all our DBAs in a room, DBAs and sysadmins, whoever's going to be responsible for troubleshooting this thing. We have the cluster and whatnot, all our tools up on a projector. We take one person out of the room and we go send them for coffee or margaritas, whatever time of day it is. Send them out. While they're gone, the rest of us agree on one way to break the cluster or the log shipping. We're not going to do all kinds of changes because that doesn't really simulate what happens in real life. We're just going to break one thing, like trash one LUN or have a duplicate IP address on one cluster resource. Then bring that person back into the room and say, it's down, go. No one's allowed to say anything. All we do is take notes while that person troubleshoots, because we want to see what it takes for them to bring this thing back and how their troubleshooting process works. I want to see their thought process. I want to see how they work through these things. Then after that, after they get done fixing it, then we talk together as a group. All right, what do those symptoms look like? Where can we go quicker in our troubleshooting in order to get done with this faster? The only wizard in here, there's two. There's the failover cluster validation wizard, and there's the setup wizard for SQL Server, and that's it. There's not really, well, you could argue that there's also a log shipping wizard. This is not really wizard focused at all. It is a lot of manual work, and you don't have to do it all every single time you build a cluster or every time you put in log shipping. But the first time you go to work at a company or the first time you walk out of this class and you go to do a brand new server build in your environment, you have to step through this entire thing, and it doesn't cost money. None of what I described involves buying big monitoring tools or enterprise edition. It just takes you the force of a senior DBA, of someone to come in and say, we are going to build something super reliable that's going to stand the test of time, unlike these unreliable shacks that I have, these filthy, nasty shacks that are the rest of my database servers. This takes a lot of time. Typically, when I talk about one of these builds, it's not unusual for it to take 3 to 4 weeks. Now, it's not 3 to 4 weeks of straight work. It's a couple hours a day going in there and poking around, because we're also doing break-fix tickets on other SQL servers. But it just is a delay. But when this thing is done, it's bulletproof. I start here. This is the first module that we talk through, because I want you to get the kind of approach that a senior DBA needs to take. You need to leave a trail of reliable, bulletproof servers behind you. People need to go, wow, that person, they did some great work. We need all of our SQL servers to look like this. It means you spend less time on call. It means you spend less time putting out fires. Now, doing all of this is hard work. This helps set the tone for what we're going to talk about the rest of today, for sketching out architecture for high availability and disaster recovery, what it means to look at, say, cluster quorum or how much data we're going to lose. We're going to take our first bio break here.